Alright guys, yes you have a sub today, but I guess in a way I'm still teaching, so please make sure you're on 9.2 notes in your packet if you do not have your packet. Alright, then write them on a separate sheet of paper and transfer them to your packet. Alright, so 9.2 notes. We're going to talk about strong acids and weak acids, strong bases and weak bases, and learn how to calculate pH. And make sure you stick with us. Alright, if you need to pause, just let the substitute know to pause, and they will substitute will do that. Okay, make sure you get all this down, and then after this is over, you're going to do the 9.2 worksheet that's also in your packet. All this needs to be done and completed by tomorrow. Okay, so make sure you have this done. Here we go, strong acids and weak acids versus strong bases and weak bases. Alright, so acids and bases are solutes that dissolve in water. Oh, look at us already going back to a definition right here. Solutes, remember that is what is being dissolved, okay? So they are solutes, they're being dissolved into water. Acids and bases ionize in water to produce electrolytes. Okay, and if you remember, we've talked about electrolytes before. This is a solution of water that can conduct electricity. Alright? And this term ionize is new here. We've kind of talked about it before, but we used a different word. We used dissociation, okay? So this word ionize here, right? Ooh, that's the worst underline ever. This word ionize here is the same thing as dissociation. I hope I spelled that right. All right, dissociation. So that means the ions that make up the acid and base are breaking apart. So for acids and bases, they both conduct electricity. They are electrolytes. All right. And we use a conductivity apparatus. We've used them before in class. Remember, we had this one right here with the light that lit up if it conducts electricity. In the picture down here, we have a light bulb. Okay? So this is a conductivity apparatus. Basically, when you put it in, the light will light up. That means the solution conducts electricity. That means it is an electrolyte. Wow. I still can't underline very well. So, if you put a conductivity meter into an acid or base, it will conduct electricity. The problem is, how well will it conduct? So here we go. We're going to look at the difference between strong acid and weak acid, strong base and weak base. Okay? So, how well does the solution dissociate? A strong acid and base dissociate 100%. That means when you put the acid and base into water, it completely breaks up. So HCl is a strong acid. Every time you put HCl into water, you get a high H plus and a Cl negative. They completely dissociate. As opposed to a weak acid and base, they only partially dissociate. Okay? When you put vinegar into water, right? Vinegar is a weak acid. It only partially dissociates. Okay? So let me see here. So the formula for vinegar is HCH3COO. When I put this in water, some of these will break apart and produce hydrogen and the acetate ion, right? But not all of them. Some of them stay in this form, right? That means dissociates less than 100%. If that happens, then it's a weak acid, or if it's a base, a weak base. Next, the amount of ions in solution. 100% of the acid and base turn into ions when it comes to strong acids and strong acids and strong bases. Less than 100%, okay, for weak acids and weak bases. Next, what are the amounts of electrolytes? Okay, we considered a strong acid and strong base 100% electrolyte solution. Weak acids and weak base, less than 100%. And then how well do they conduct electricity? We've already said that they both conduct electricity. Right? Acids and bases, no matter strong or weak, they all. But you'll see here that strong acids and strong bases are excellent conductors of electricity. If you put the conductivity meter, right, into a strong acid or strong base, the light is very, very bright. But weak acids and weak bases are poor conductors. They do conduct, but if I put this, okay, into a weak acid or weak base, the light would be really, really dim. Alright, so once again, strong acid base, very bright light bulb. Weak acid and base, very dim light bulb, and you can see the difference in the two here. Okay, so if these were hooked up to an apparatus, a conductivity apparatus, strong acid or strong base, very bright light bulb. Weak acid, weak base, very dim light bulb. All right, give you a second to copy that down. Moving on. All right, so label the beaker as either a weak acid or weak base, or a strong acid and strong base. So label these two. So let's look right here at this one. We got our beaker, it's got a liquid in it. Here's our conductivity apparatus. This one's a little more fancy. We have a very bright light bulb. So you should have down that this is a strong acid or base. We don't really know what it is, but if the light bulb's on bright. So we got another thing here, and it should be lit up just a little bit, so we'll get a couple lines coming here. So it's a little bit lit up. Okay, this would be a weak acid, or if it was a base, a weak base. So strong acids and bases, bright light bulb. Weak acids and bases, not a very bright light bulb. Okay, moving right along to neutralization and pH. Pop some stuff on there so you can write. All right, what the heck does pH mean? pH actually means power of hydrogen, or if you remember yesterday, I brought up this term hydronium, okay? And I told you, and hopefully you remember, that when it comes to acid-base chemistry, hydrogen ions, and the hydroniums, H3O+, these terms are used interchangeably. Power of hydrogen or power of hydronium is what pH means. It's actually a French. All right? Or it came from the French. And the pH scale, we've talked about it a little bit. pH scale lets us know if something's an acid or a base. It knows its acidity or alkalinity. If you remember, alkalinity is referring to how basic something is. pH range is from 0 to 14. All right? And we can measure pH either qualitatively or quantitatively. Qualitatively is when we use our indicators, right? Remember our litmus paper? If it's an acid, it turns red. If it's a base, it turns blue. That's qualitative. It's only telling us whether we have an acid or base. Quantitatively, we have these things called pH meters. You take the meter, you put it into your acid or base solution, and it'll give you a number and tell you the exact pH. So, how do we calculate pH? All right. pH is equal to the negative log of the hydrogen ion concentration. Another way to write this is pH is equal to the negative log of the hydronium ion concentration. Remember, these things can be used interchangeably. So if I want to calculate the pH, I have to know the concentration of hydrogens that are in my solution. If I know this, I just plug in the number and do negative log. Now, this log thing is probably something you've never seen before. Maybe a few of you, but you probably have never seen it. Okay, we're not going to go into a lot of detail of what log means. I'll let your math teacher do that. However, I will show you how to use it on a calculator and show you how to use it on the calculators we have in class. Okay. So what does log mean? Basically, this represents a 10-fold change in pH. Log is not just on a you go up 1, 2, 3, 4. It actually goes up by bases of 10, meaning when I increase it, it goes up like 10, 100, 1,000, 10,000, 100,000. So 10 times as much as you go up on a logarithmic scale. I'll explain more. All right. Oops. pH scale. So if this is our pH scale, if we're on the 0 side, we have lots of hydrogens and very little hydroxide. We're on this side, we have lots of hydroxides and very little hydrogen. If you're in the middle, you have the same amounts. And so, if we're on lots of hydrogens, we're an acid. If we have lots of hydroxides, we're a base. And if we're in the middle, we are neutral. Alright, so we're going to take a look at these. Oops, I didn't mean to pop that up. All right, how much more acidic is a soft drink than coffee? All right, so this is kind of give you an understanding of how logarithms work in the pH scale. A soft drink is a pH of 3, and coffee is a pH of 5. So how much more acidic is the soft drink than coffee? So first thing we want to realize is this. The lower the pH, the more acidic. Okay? So I want to take the difference in these two, and the difference is a pH of 2. Now, this does not mean it's 2 times stronger. Okay? Logs go by a base of 10. So it's actually 10 to the second time stronger, or to be able to do this easily, you just take the difference in the pH, put a 1 down, and add how many zeros behind it is equal to the difference in the pH. So 5 minus 3, the difference here is 2. So I'm going to put 2 zeros behind it, or this is 100 times, right, more acidic. And you're going to see right there as I wrote over my numbers, all right, soft drinks are 100 times more acidic than coffee.
Please excuse the interruption. If Yanea Correa is in the building, please come meet your ride in the front entrance. Yanea Correa. Thank you.
All right, we'll keep on. How much more acidic is stomach acid than coffee? Okay, we have coffee again as pH of 5. Stomach acid is about a pH of 2. So once again, I'll take these. The difference in these is 3. So you can do it one of ways. You can take 10 to the third power, or you can just say put a 1. And the difference is 3, so 3 zeros added to it. 1, 2, 3. So this is going to be 1,000 times more acidic. Okay, if you take the difference in these two, stomach acid is 1,000 times more acidic than coffee. All right. Oops, did it again. This one's asking something different. How much more alkaline is oven cleaner than seawater? All right, alkalinity is another way of saying how much more basic is this. Remember, for bases, the stronger ones are the higher number. So for acids, the lower number for pH is more acidic. For bases, the higher number. So I want to know how much more basic this is, or how much more alkaline. You do the exact same thing. Okay, we're going to subtract our numbers here. All right, so 8 from 14 is actually 6. And it's 10 to the 6th power, or you just put a 1 down, and then 1, 2, 3, 4, 5, 6 zeros, or you can say 1,000,000 times. Okay, so oven cleaner is 1,000,000 times more alkaline than seawater. One more to do. All right, which has more hydroxide ions, detergent or hair remover? How many more? Okay, so more hydroxides you have, the more alkaline you are. Again, that means more basic. So the higher the pH, the more alkaline you are. So which one has the higher pH here? Well, that would be hair remover. How many times more? Well, subtract these. You get 10 to the third, or 1 with 3 zeros. That means this is 1,000 times more alkaline, or another way to say that is actually this. You have 1,000 times more hydroxides. All right, that's what the pH means. Okay, when you put these numbers out here, if you're talking about, so I'm going to go back real quick. If you're talking about your acids over here, all right, soft drinks have 100 times more hydrogens than coffee does. Stomach acid has 1,000 times more hydrogens than coffee does. For the bases, oven cleaner has 1,000,000 times more hydroxides than seawater does. Hair remover has 1,000 times more hydroxides than detergent does. That's how you kind of look at pH. All right, so how do you plug these into your calculator to find pH? Okay, what's the pH of a solution when the hydrogen ion concentration is equal to 3.0 times 10 to the negative 6? We want to remember, that the equation for pH equals the negative log of the hydrogen ion concentration. So all you do is take this number and plug it in. I'm going to show you two calculators on how to do it. First, if you have a fancy graphing calculator. pretty straightforward. You just hit negative. The log button is right next to the 7. Okay, so hit negative log, and then type in 3.0. Hopefully you remember how to do scientific notation. It's just second e to the negative 6 power. Close your parentheses, press equal. My number came out with 5.5. Right? If you have one of my calculators, all right, here's what you have to do. You actually have to type in the concentration first. Okay? So the first thing you're going to do is type in your concentration here. You're going to type in 3.0. Remember how to do scientific notation on this one. You just hit the EXP button, exponent, and then type in negative. The negative button is right above the 7 on my calculators. Okay, so right above the 7, if you push negative, it should pop up for your exponent. So negative 6. All right, you can press equal if you want. All right, now, we're still not done with my calculator. So you got 3.0 times 10 to the negative 6. You are now going to hit the log button here. If you go all the way to the top of the row of buttons, you'll see the one that says LOG, log. Hit it. Once you hit it, hit the negative button one more time, and you'll see it again. It says 5.528, blah, blah, blah. Okay? So 5.5 is good enough, and boom, there's our answer. All right, so with this pH, is this an acid or a base? And if in your head or out loud you just said acid, you're correct. All right. Are there more hydrogens or hydroxides in this? Are there more hydrogens or hydroxides in this solution? All right. Since it's an acid, you should know that there's more hydrogens. All right. There is also this thing called pOH. So, pOH is very similar to pH, except it's opposite. The formula looks the same. Now they got an announcement going on. Give me a second. So, when you find it mathematically, you do pOH is equal to the negative log of the hydroxide ion concentration. So, for this one, now that we're doing pOH, it's going to be the opposite of our pH scale. This one sometimes gives students trouble. Okay? I would suggest, in just a second, I'm going to show you if you have pOH, how to find pH. All right? But a low pOH actually means it's more basic, and a high pH means it's more acidic. That's flipped of the pH scale. All right? So, our formula, pretty much the same thing as pH, except it's the hydroxide ion concentration. So moving right along, find the pOH of a solution with a hydroxide ion concentration of 4.0 times 10 to the negative third. Again, follow along with me in your calculators. If you have one of my calculators, here we go. All you got to do is type in 4.0, hit the EXP button for exponent, and then hit the negative right above the 7. All right, hit the negative, and then 3. So on your calculator, you should say 4.0, then to the negative 3. Okay? And then you hit the log button. So up here, top row, hit log. Just press the negative button one more time, and you'll have your answer. So the pOH is equal to 2.4. All right, is this an acid or base? Be careful. We're now talking about the pOH scale. And remember on this last one, the low pOH, below 7, right, is more basic, and above 7 is more acidic for pOH. So since it's 2.4, this one's a base. All right. So one more calculation to show. This one's a fairly simple one. If you have the pOH, you can easily find the pH and vice versa, because pH plus pOH is equal to 14. You need to know this. pH plus pOH equals 14. So if the pOH is 2.4, calculate the pH. Well, simple enough. pH plus 2.4 is equal to 14. So pH is equal to 14 minus 2.4. Right? I just subtract that over to get pH by itself. And when you do this, you should get a lovely answer of 11.6. Boom, there we have it. Alright, so if the pH is 11.6, once again, that makes this a base. Okay, so you really don't have to remember how pOH works in terms of trying to figure out whether it's an acid or base. If you plug it back into here, you can find the pH, and just know the pH scale. Below 7 an acid, above 7 a base. Alright, we got some to try. It says you try right here. I'm going to help you out with these. So work them out as I'm working them out. So we can identify the pH, the pOH, whether it's an acid or base. Here we go. Alright, if I have a pH of 12.3, what is my pOH? Well, remember, pH plus pOH equals 14. So we got 12.3 plus pOH is equal to 14. Subtract that over and you should get, oops, I just put in the wrong one. Alright, you should get a lovely number of 1.7. We're going to leave these out. So if my pH is 12.3, my pOH is 1.7, is an acid or base? Well, you probably just saw it pop up there, but a pH of 12.3 is a base. And there we go, 1.7. Alright. Next one here. I give you the hydrogen ion concentration. So if I know this, I can calculate my pH. How do you do it? Well, let's remember the equation. The negative log of the hydrogen ion concentration is equal to pH. I'm going to put it back up here. pH is equal to the negative log of the hydrogen ion concentration. They gave us it. It's 6.30 times 10 to the negative 11. I'll use one of my calculators again. So to find the pH first, you just do 6.30 exp negative 11. Hit the log button and then the negative button and you'll have your pH. I got a pH of 10.2. If you know your pH, remember pH plus pOH is equal to 14. So if I know my pH, subtract it from 14 and you'll get your pOH. So if this is 10.2, then I subtract from 14 and I should get 3.8. Oops, and there we go. And I went ahead and answered that accidentally. Alright, so if the pH is 10.2, we know we have a base. Ooh, tricky one here. I give you the hydroxide ion concentration. The pOH is equal to the negative log of the hydroxide ion. So, if I plug this in, 6.4 exp to the negative 9th. Hit the log button and then hit negative again. I get 8.2. Alright, now be careful. This is hydroxide, so I just found pOH is 8.2. Find pH, plug it back into our formula here. pOH plus pH equals 14. Subtract from 14. And you should get a lovely number of, what's that, 5.8 I think? Is that right? There we go, 5.8. So all we did is subtract here. And if our pH is 5.8, our thing is an acid or base. And if you're in your mind or out loud, you just said acid, you were correct. Last one is pOH is 7.5. What's our pH? Subtract them here. Alright, if the pOH, if the pOH is 7.5, subtract from 14, and you should get 6.5. If the pH is 6.5, is this an acid or a base? Hopefully you said acid. Alright, so let's summarize. These are the equations you need. If you haven't written them down yet, write them down right now. Alright, this is for pH, pOH, and pH plus pOH equals negative 14. You're going to need these. All right, these are the notes you had to take today. So you should have all the blanks now filled in. All right, for 9.2 notes. Okay, we went over. So please make sure you've done that. If you've missed anything, we can rewind or whatever. And if you got everything, you're now onto the 9.2 worksheets. The 9.2 worksheet. If you get completely finished with 9.2, I expect you to go back to 9.1 and finish those up from yesterday. So please finish up the 9.1 from yesterday if you have not. Remember, this entire packet is due on test day. And if you haven't heard me yet, test day is next Wednesday, okay? Next Wednesday is test day. Not tomorrow, okay? But next Wednesday is your test. All right, so please get this done.